In this video I'm looking at the solution to question 3 of the January 2011 Edexcel D1 paper. The topic of this question is minimum spanning trees. So the question shows us a figure 2 which is showing a network and asks us in part A to use Kruskal's algorithm to find a minimum spanning tree for the network shown in the figure. We're asked to list the arcs in the order in which we consider them, and in each case state whether you are adding the arc to your minimum spanning tree. In part B of the question, we're asked to find a minimum spanning tree, this time using Prim's algorithm starting at A. Part C asks us to draw a minimum spanning tree for the network using the vertices given in diagram 1 on the answer booklet, and we're asked to state the weight of the minimum spanning tree. It says a new spanning tree is required which includes the arcs D, I and HG, which has the lowest possible total weight. And it says explain which algorithm you would choose to complete the tree and how the algorithm should be adapted. Well, let's do this then part at a time. In the first part of the question we're asked to use Kruskal's algorithm to find a minimum spanning tree. Now I would always suggest that when you're doing either of these algorithms, you always draw a minimum spanning tree at the same time. So we will use the diagram 1 for Prim's later on, but I'm going to start off with my Kruskal's algorithm. Remember, with Kruskal's you find the arc of lowest weight. Now we can see that looking through that is CI. So the first one to consider is CI, and I'm just going to keep a track of what my spanning tree looks like. So I will just mark a little diagram like this, CI. And then going through, the next shortest one is CD. So yeah, we can use that one. So that's coming in CD. And then the next shortest one would be DI, which is length 26. But we're not going to actually consider that one. So, but let's write it down and say not DI. And the reason for that is it would produce a loop. So we can't join D to I because that would produce a loop CDI going round there. The next one to consider is EF. Now EF is over this part of size 28. That one comes in. Followed by FI. So FI coming in at this position here. Then EI and DE are the next ones to look at, of size 34. So I beg your pardon, 34 would be the EI, but that one's not going to come into there because again we'd have a loop, and likewise DE we're not going to use. So let's write that down, that we're not using EI, which was 34, or ED. HI is the next one. HI coming in 39. Well, yes, we can use that one. So HI. And then the next smallest one is BI, size 42. Now, I beg your pardon, before that we've got BC coming in at 39 as well, and that one could equally well have been done before we did HI, so we've got BC. But then we can't use BI because that is going to again create a loop. So let's write that down, not BI. And then GF is our next one at 43. And yes, GF comes in here. Going on from there, so let's write that one down, GF. Then we have GI, which is 45, but again that's going to create a loop, so we can't use that one, so not GI. And HG again would produce a loop, so not HG. That was GI, HG. And then finally we've got AB added in. And there we've got our minimum spanning tree. The marking for this part of the question was to give an M1 for 4 correct chosen arcs, and then A1 for all of them correctly rejected, and then a final A1 mark for the solution. That's what's correct answer only. So you only get that final mark if your minimum spanning tree was the correct. There's no follow through mark there. Well, in the second part of the question, we're asked to use Prim's algorithm to find again the minimum spanning tree, and we're starting at A. So starting at A, we go to the next nearest point with Prim's algorithm, which is B. So we start off with AB, and I'm going to complete the next part of the question at the same time. So AB is the first one that we considered, and then we look at both A and B to see what that joins up to. Well, A joins to I with 53, but B can be joined to C with a shortest. So the shortest one there is BC is 39. Now, of course, having already got our minimum spanning tree, it's going to help us to do this part of the question. So from AB, we've got BC. And then the shortest one after that is from C to I, which is 19. So that's coming in here, C to I. And then from C to D is 23, but do check around making sure there's nothing smaller than that. From C to D is 23. And then FI is the next one, 31. EF is in here at 28. IH 39. And then finally we have from F to G, which is 43. And then we have minimum spanning tree completed. The weight of it for the next part of the question, the total weight is just adding up those values, and that comes to be 270. So the marking for that was in the Prim's algorithm part was to get an M mark once we got the 4 parts, then and then further A marks for getting the next ones correct. So, and finally, if you got the full diagram, it was a total of 3 marks for that part of the question. Drawing the diagram itself, B1, and stating the 270, a further B1. In the next part of the question, we're asked to say how we would adapt one of the algorithms to include two particular arcs, di and hg, and then to find a spanning tree of lowest weight including those. So we have to use the one where we're choosing arcs, the size at the time. So it would be Kruskal's algorithm, but we would start with the required arcs di and hg already in place. So we'd use Kruskal's algorithm on the remainder of the network once those two had been put in place. Just 2 marks there for getting the Kruskal's algorithm with an explanation of the way it's adapted. Well, that's the end of the solution to that particular question. You can find solutions to other questions at www.furthermaths.org.uk.